In this video, we use Abaqus beam elements to model the frame shown in this slide. The material of the frame is steel with Young's modulus of 200 gigapascal and Poisson's ratio of 0.3. And this is the cross section of all the beams and columns of this frame. Let's go to Abaqus. We're going to start creating the part. Initially, I create the front part of the frame and then I will create the back part. So click on create part. It's a 3D frame, deformable, and I choose wire as the base feature and planar is the only option. Continue, and let's create the front frame. And we need to apply dimensions to get the dimensions given to us. The columns are 6 meter, actually 5 meter. So we select 5 for all of them. And the beams are 10 meter. After assigning the dimensions, done, and this is the front part of the frame. So basically we have 5 meter columns and 10 meter beams. Now to create the other frame in the back, we are going to use the wire frame, and for that purpose we need to have datum points. So what we are going to do first, we are going to click on create datum points. If this option is not shown to you, click on this and hold your mouse key down, and the second option, choose the second option, create datum points by offsetting. And what we are going to do, we are going to offset these 6 points 15 meter in the Z direction. So select this point and 15 meter in the Z direction. If you look at it, if I rotate this a little bit, you can see that now we have a datum point here. And we are going to do the same thing with all the other 5 points. And this one, and finally this is the last one, 0, 0, and 15. So we got all the points that we need. Now we can use the create wire feature, and again, if this option is not shown to you, click on this and hold the mouse key down, and the second option, which is create wire point to point, select that. And here we are going to change this one from chained wires to disjointed wires, and click on add. So let's select this point and this point as a second point, done. We're going to add more, this point and this point, and again this point and this point, again this point and this point, and this and this. And now we need to create the beams between the two frames. So this is the geometry of the frame. Alright, now that we have the geometry, we can go to the property create material, steel, and it's an elastic material with a Young's modulus of 200 gigapascal. Since I'm using kilonewton for forces, my unit becomes 200E6 kilopascal. Because of my units, the value I'm choosing here is going to, because of the units, the value of the Young's modulus is going to be 200E6. Poisson's ratio is 0.3. Now create section. Our section is a beam. I'm not changing the section name because we have only one section. Continue. We need to define the cross section for the beams and columns. Our cross section is an I shape, has an I shape, so we select I and continue, and we just need to enter the dimensions based on the dimensions given to us by the problem. And remember, the dimensions given here are all in millimeter. We need to convert them into meter here. .359, 0.172, 13 millimeter, 13 millimeter, and finally 8 millimeter, the last one. All right. Now the material name is steel. That's the only material we have defined, and okay. Now that we have defined the section, we can assign the section. All the beams and elements have the same section, so we select all of them and click done. And the only section we have also is section 1. All right. Now we have assigned the section. The last part is to assign beam orientations. So click on beam orientations and select all the beams and columns which are not in the Z direction first. Done. And the default is fine here for these beams and columns. We assume that the N1 direction is in the Z direction. We repeat the same things for the remaining beams. So select these 3 beams. Done. For these beams, we assume that the neutral axis is in the X direction. And remember, the default is not going to work because the beams are in the Z direction themselves. All right. So these are, we have assigned the beam orientations. If you go to view, part display option, general, and render beam profile, then you can see that the beams are assigned the way we wanted them to be oriented. So this is good. Now we go to assembly. We bring an instance of this frame as a dependent instance to the assembly. Then we go to a step. We create a step here, a static step, and all the defaults are good here. We modify the default field output requested here, and click on edit. And what we are going to request is the section forces and moments and the nodal forces in beam, and dismiss. The nodal forces in beams, we are going to use them to plot the shear and bending moment diagram. Now let's go to load. Let's assign the supports, and I call it a fixed support. Continue. we select the bottom point of all the columns, and we fix all the translational and rotational degrees of freedom. Then we apply the loads by creating loads. The load that we have is a line load, and we select all the beams. Done. And the global system is fine here because of the orientation of the beams, and the load is applied in the y direction, and the magnitude of the load is 15 kilonewton per meter. Okay. Now we need to mesh the frame. Let's seed it first. I need to mesh it on the part because this is a dependent instance. So let's select all the frames. To see it better, I'm going to turn off the beam profile, and we select all the beams and columns, and we want to use, let's say, 5 elements to mesh each beam and each column. The second thing is to assign element type. Let's select them all. And linear beam elements are good. These are 2 node linear beam elements. Again, if you choose quadratic, they become 3 node beam elements. For this problem, I use 2 node elements. And finally, we mesh it, and the frame is meshed. To see the mesh, go to View, Part Display option, Mesh, and turn on the node labels and element labels. And okay. So I turn them off again. Now we can go to Job and create a job. I call it frame. Continue. Defaults are good. We can submit this job. And it should take a couple of seconds to finish because we don't have many elements. All right. So the job is completed. So let's look at the results. Right click on the job and select results to go to the ODB file. So here you can look at the normal stresses in the beams and columns. We can plot the shear and bending moment diagram by using this output variable. So this is the shear force in the y direction, and and you can see that the maximum value and minimum values are also shown, and their locations. We can turn it off by clicking on this, and on the limit we turn this off. And if I want to see the diagram better, what I can do, I can go to contour options, basic, and turn on the tick marks. And if I have the contour plots on the undeformed shape, then you can see that we have the shear and bending moment diagrams plotted for us. Okay, I can change it to, this is bending moment about the Z, and this is the other bending moments. The other way we can create bending moments is by defining, by plotting the values of internal shear force or bending moment over a path. So let's try that. Let me turn off the tick marks. So if I create a path here, I have already created one path before, so this is the default for this is path 2, which is fine. Continue, and I create a path over this frame, over this beam. Let's plot the shear and bending moment on this one. So we select the nodes of this beam. So these are all the nodes for this beam. Click done. So we have a path defined. Now if you go to XY data, create, and this time choose path, continue, and we want our bending moment to be plotted over this path. So the field output variable is already set to the bending moment. So let's plot it now. So this is our bending moment. If you want to plot, for example, the shear force, you can change this to SO2 and click OK, plot. This is the internal shear force. Similarly, if you want to see the shear or bending moment diagram over other elements or columns, you need to define path for those beams and columns as well. Similar to before, you can use the report option to create a report for yourself, basically for the stresses or support reactions, as we discussed in the previous videos. Alright, thank you for watching this video.